Welcome to Smarter Circuits. I'm your host, Ian Klein, and since this is the first episode, I suppose I should take a moment to tell you what Smarter Circuits is. Smarter Circuits started as a home automation project with the purpose of demonstrating how smarter houses can improve comfort, efficiency, and safety in our lives. The prototype has been in every house I've lived in my adult life. This channel serves as the medium for this project, as well as a way to demonstrate even more ways that Smarter Circuits can better serve our needs and comfort. Mostly, I'll be focusing on lighting, heating, cooling, and monitoring your home in ways that are surprisingly cheap and effective. The reason for this first video is to show you how I came to build this latest iteration of my smart home with a unique type of electrical setup that some of you may be here specifically to see. Hang tight and we'll get there. In this first episode, I'm going to cover some history and the components of an interesting home lighting control system commonly referred to as a low-voltage lighting system. This has some ambiguity with more modern low-voltage lighting that actually is low-voltage lighting, but you'll quickly be able to tell the difference. Also, the creators of these older systems first called them remote wiring systems, which is a better definition, although I prefer the term control voltage variable electromagnetically isolated circuit switching, which was never used by anyone so far as I can tell. In future videos, we'll cover things like thermostat functionality and improvement, programmable roller shades, home camera systems, and more, but before we get to all of that, I'd like to explain a bit of my history with home automation and how a few interesting coincidences led me to start building a more robust and practical smart house, the present version of which uses the groundwork someone laid in 1954. The idea of a smart house is not new, which is obvious to anyone who knows anything about Epcot, the World's Fair, or has read any science fiction from pretty much any time. I won't go into historical details or elucidate on the particulars of how high-end comforts trickle down into the working class as they become less spectacular, but I will say that some things only the elite could even imagine are now pretty mundane and available. It is obvious that quality of life can be easily measured by convenience as well as comfort, so why not have a little more of both? After all, like George Jetson, what more could anyone want after a long day's button pushing than to come home to discover the robot maid has already tidied up, the chair is waiting to give them a nice back massage, and the home theater system is already springing to life to bring them whatever entertainment pleases them? Of course, an outdoor treadmill several hundred feet in the air seems a bit hazardous, but George Jetson's home is a prime example of a future barely realized. I won't be analyzing the social or economic commentary associated with the Jetsons, I'll leave that for the comments section, but not too long ago I realized that we're much closer to those ideas in ways we might not readily identify or appreciate. While my Roomba isn't rosy, it does a fair job of keeping the floors clean. If you're too young to have seen the Jetsons, find it and have a watch. It's an interesting window into a vision of the future from the past. We had some pretty wild ideas that were either too novel or seemed too far-fetched for practical application at the time. There are a lot of ways automation and computing have already blurred what's possible and practical. There's a car in space, but I think the outrageously exaggerated image of the smart home in our fiction has prevented us from looking deeper into some really good ideas. In fact, I think it's even preventing us from giving some ideas a second chance or new purpose. Sometimes novel is just practical used in a trendy way. This brings me to one of the reasons I'm making these videos, the GE low voltage lighting system, or maybe it's Remcon, but it could also be Bryant, maybe it's Touchplate or Sierra. Okay, this is going to get a little confusing and somewhat foggy. I'm sure any and all inaccuracies or flaws will be meticulously listed, corrected, and judged for severity in the comment section for the viewer's convenience. Before I talk about the low-voltage lighting system and how it relates to smart homes, although I'm sure you can imagine a bunch of ways on your own, let me give you some background on my home automation history prior to discovering this strange new old thing that was once itself only available to those who could afford a car with air conditioning. Although I dabbled in voice recognition, programmable logic controllers, automation programming, and the like for over a decade, a smart house always came with logistics or architectural challenges that drastically increased the cost and complexity of these systems, ultimately rendering them impractical on several levels. The biggest of these was where to put the relays, how to communicate with their controllers, and centralizing infrastructure in general. My earlier systems used much larger contactor relays with heat sinks because they were readily available to me, and I wasn't yet certain of how much of a load I needed to put on them. The circuit breaker would, of course, protect anything from the mains box to my circuit, so I wasn't concerned about having larger relays, well, at least not for that reason. When I wasn't using salvaged industrial electrical equipment, I was buying higher-end gadgets for their reliability, compatibility, or just their uncommon function. There were large junction boxes and long runs of not only power wire, but also communications, all shielded and protected. I had hardwired microphone arrays, sensors, and a lot of other things like solenoid valves that I've yet to reintegrate with the current system. I built some impressive stuff, but it was expensive and required some rather specific knowledge to install safely, as well as troubleshoot, particularly systems that controlled water, like the temperature self-adjusting shower and the hot water radiant heat flooring systems. I will rebuild these in the new home with now cheaper and easier to use equipment and do some videos later in the series on this. At any rate, the systems I made were simply impractical for most people, and some still bordered on outwardly novel. At one point, I even gave up on my own system upon hearing that companies like Google were working on home automation systems with their super fantastic voice software. I honestly believed that would work out well. It hasn't. Compared to the vision sci-fi writers have painted for us for at least decades, these home assistants are crackerjack toys, flimsy versions of what they could be. Sure, they can do some nifty tricks like playing music and flipping a light or two on or off. There's even some scene support and robot vacuum integration if you want to relive the 90s plug-and-play experience, but you're also required to connect to third-party apps and jump through a ton of hoops for very little control and even less reliability in some cases. You might even be exposing your home to potential hacking that could result in fires, though I'll be covering the real threats and risk on this subject in another video. Don't get too paranoid too quickly. Overall, these products do what they advertise, and some are even secure insofar as you trust the guys that made them. It's just that they're not much more impressive than the clapper and a timer, both readily available even 40 years ago. But what if I want a system that simply turns on a light only when I need it and without a cue or trigger other than my own presence? Motion sensors and timers are a great start, but they can have annoying side effects where you end up waving your arms around to keep your bathroom lights on. There is a way to perfect this approach by adding one simple device to the equation, and I'll be doing a video specifically about this later on, but the point is that there are many ways to combine imperfect technologies to get a more perfect result. One might say the whole is greater than the sum of its parts. Before I go too far down that road, let's get back to the GE low-voltage lighting system and how a really stupidly simple concept from the 1950s came to be the backbone for a smarter house that's arguably better than anything off the shelf and probably cheaper than you'd think. For those of you watching because this is one of 5 videos on the entire internet about these old low-voltage systems, this project is also a way to avoid spending thousands of dollars on a possibly unnecessary conversion. A conversion that would require running a lot of new wiring and switches, a pretty intrusive process for the house and for you, the occupant. Now, you should still replace any old out-of-code wire itself if necessary and test the hell out of all control wires if you plan to use them, but if all that is good, you may not need to put an electrician's kids through college just to have a more reliable lighting system, or even more. I welcome homeowners with these systems looking to figure them out to contact me, especially since each installation seems to have a personality and complexity of its own. I can provide a plethora of information, not included in this video because, well, it was boring or I didn't have proper video or pictures, but if you haven't already done so, I highly recommend checking out Kyle's switch plates, linked below. They have a lot of replacement parts, updates, upgrades, and information on these old systems I'll talk about shortly. I'll include a few other links with more interesting stuff on these systems as well. I want to make one more note here. I am not trying to teach you how to build your home automation system. There are plenty of guys and gals that build much more elaborate things out there, but I am trying to show you ways of thinking about the problems you want to solve that might be easier or most effective for your specific purposes. Of course, if I'm doing something that works, go ahead and copy it. When I consult on a conversion of any kind, I do so with a qualified electrician present, as I myself am not an electrician. I'm a software engineer by trade, and I happen to have an adequate understanding of electricity and physics to safely make some useful things. Or not useful things. We all have hobbies. Although, I hate to have to do this, humanity will humanity. While I intend for this to be both entertaining and educational, please do not use this as your sole reference material for any project. After all, I got a lot of my information from the internet. Even if I were face-to-face with you, I would not be the sole subject matter expert on site. So, about my system. Earlier this year, 2021, for those of you who have me in full screen and can't see when this was made, I bought a house. This is the part where I actually get to the point I was trying to make a few minutes ago. When my wife and I were first shown the house, we saw that the light switches weren't toggle switches, but instead momentary, and there were sometimes 3 to a single plate. In one instance, there was even a weird rotary dial and switch combo. I'll talk about that in a moment. The first time the real estate agent touched one of these and I heard the telltale click of an electromagnetic switch come from the basement, I was pretty excited. I wasn't sure what kind of switch it was, but I knew it was going to be something that I'd like, or at least something that I'd like to tear apart. The real estate agent referred to this as a soft switch system, which is the first, last, and only time I heard it referred to as such, but it totally should have been a name they used because the momentary switch requires little force to operate, even though the newest ones are over 30 years old. This easy, smooth motion is actually a problem I'll talk about later. Clever folks will already know why. Upon examining the basement, I noticed 2 metal cover plates on the wall in the garage area. My house is a split level, which has other advantages I never anticipated, and I'll talk more about those in future videos regarding heating and cooling systems. In the laundry room, on the side of a massive breaker panel, lives an absolutely ludicrously massive step-down transformer. There's actually 2, but one goes to the old doorbell, and it still works, though no one uses it. Some systems require more than one transformer, depending on how many switches there are and how far away they are. More on this later. The day after moving into the house, the lights in the kitchen above the bar turned on, but never turned back off. When you pushed the switch down, you could hear the relay buzz loudly, and the lights would momentarily go out, but after releasing the switch, the lights would just stay on. I'll explain why this happened shortly. A few days went by before I had the time to crack open the relay box and try to diagnose the issue. What I found was a rat's nest of wires and 19 latching solenoid relays like this one. In fact, this is one of the relays I removed from my system. This particular one is a GERR7. However, there were several other models from other companies in the panel. So I started digging. What I found wasn't as surprising as what I didn't find. There is a really limited amount of readily available information on these systems. First, I found a site for an electrical supplier, Kyle's switch plates I mentioned earlier, that specializes in replacement parts and seems to have a fondness for these old lighting systems. They have a really awesome feature on their product pages that really came in handy. It explains things like modern light bulb compatibility as well as some history. This led me down a rabbit hole that could only logically end in one place, the U.S. Patent Office. Now, admittedly, I did not search other countries for these patents, and I'm sure it's possible these systems existed in the appropriate forms in other areas of the world prior, but it's probably safe to say it was close-ish if that's the case. There are several patents that use various methods of latching relay circuits to control higher load circuits with lower voltage and current controls, but mostly these seem to have been industrial, and most involved latching relays by setting them up to power themselves to stay closed. Then, in 1946, there's an important type of switch device patented. The so-called snap-action device enables the switch to maintain its state without power and is controlled by an electromagnetic coil and plunger. This device would be required to make the, at the time, modern design work safely and reliably. There were other solutions to this problem, but this one really seemed to shine for its small size, dependability, and low-cost manufacturing. Although these systems existed in the 1940s, produced mainly by a company called Touchplate, the first patent that clearly shows the most frequently used configuration is this one, approved in 1956, filed in 1953, by Edward J. Dobratz and Thomas J. Hadey. A few companies were already manufacturing and selling similar systems by this time. These companies were primarily Touchplate, GE, Bryant, Sierra, Pyramid Electric, and a few others that joined in a little later or took over for other defunct companies. It's difficult to tell at what point many of these companies started making proprietary changes to their systems, as most of them started under contract from GE themselves. The variations, however, did not deviate much from the original patent. This design, unlike most of its industrial or commercial cousins, requires a latching relay that can stay in position without power being applied so the long runs to the control switches aren't constantly energized. Yes, I used the word energized. As previously mentioned, the snap-action device allowed a solenoid plunger to push or pull a switch on or off and leave it there without any coils being powered. Mechanical memory. This seems to have been the truly unique feature that allowed these earlier systems to succeed in the residential world where others had failed miserably. For a time, these systems were must-have items for the higher-end homes of the 1950s to 1970s yuppie. Most of the companies that manufactured these products are long gone. Sierra went out of business in the 80s after being absorbed by Pass and Seymour, which was later absorbed by Legrand. Bryant Electric effectively died in 1988 after Westinghouse shut down its primary plant for deindustrialization purposes. Look that one up if you want to be depressed. And it was bought by Hubbell Incorporated in 1991. Eventually, the company dissolved in 1999. Remcon products, those really different from anyone else systems originally manufactured by Pyramid Electric and later Amprobe Instruments, continued being available all the way up to 2011 when they suddenly stopped manufacturing the control devices. This was much to the dismay of owners whose systems were incompatible with nearly all other systems, requiring them to make more modifications that usually left their systems being half one design and half the other, meaning twice the replacement parts. To be fair, Remcon solid-state relays were in production all the way up to this year, so you can probably still get your hands on a decent relay replacement, although I'd argue for a third the cost you can simply do what I've done and end up with a better system in the long run. And I promise we will talk about that soon. The point is, for all their ups and downs, these low-voltage systems were a brilliant idea, despite some of the companies that made them weird and expensive, and the way they all sort of drifted apart in compatibility and style, making each system's market smaller, and the refusal of companies to update their systems to use better relay or triggering technology, and the sheer unwillingness to reduce pricing even when cheaper equivalent components became available in order to expand the customer base, and the lack of socketed connections that would have made upgrades, repairs, or conversions easier, and the installers that simply crammed things together and gave them awful reputations with modern inspectors and electricians, and the homeowners that didn't spend the intermediary money to make them less messy when updating their homes in the mid to late 1970s with everyone else, because it was foolishly deemed unnecessary since the relay panels more or less worked safely. Despite all these things, the high-level solutions to the problems these systems addressed were quite elegant, and let's talk about that for a moment. The concept behind the low-voltage remote wiring system is fairly straightforward, even though some of the execution was a bit spotty. Rather than running the full 120-volt mains power through your light switch, you run the power from the mains box through to the relay box and then directly onto the fixture. This gives you several benefits. You can use much smaller gauge wire for your switches, as they now need to handle lower voltages at much lower currents and for only a short period of time during state switching. This is cheaper, safer, and doesn't usually require the strict routing as your heavier power wires do, so it's arguably easier to install. Although this means a lot of these wires weren't organized very well at all during installations. You can also use as many switches as you want on any circuit, and put them anywhere you can run a wire from the relay box. You also need a step-down transformer to power the relays via the switches, and because of the current draw of the relays, somewhere around 200 to 250 milliamps, various manufacturers recommended a transformer per 8 to 10 relays, but these were and are relatively cheap. The transformers and the various reasons some are absolutely awful are topics I may cover in another video, but suffice it to say that many of them simply sucked power and shedded as wasted heat energy. Going back to my stuck-on light, one of the solenoid relays had a burned-out coil, and the plunger would not move the snap-action device to break the contacts properly. This was probably due to one of the control switches in the house being stuck in the powered state too long. This is common with the age of these homes, as many switches were simply painted over or wore out over time. The gentle rocking motion of these switches in particular didn't provide much in the way of a fast interruption or a good arc gap, so many simply welded themselves closed, even briefly, and subsequently burned out their relays. This is also a difficult thing to diagnose because of the ability to hook up multiple switches in multiple locations and the rather crappy way they did this, and they certainly did. My house has 56 switches that controlled 19 of these relays when I bought the house. It looks like there were originally 24 relays. Several of the circuits had been fairly carelessly rerouted to share another circuit's relay, which I'm sure is all perfectly above board, but 56 switches is a lot. Fun fact, one of these relays was connected to a vanity that houses 10 bulbs. When we moved in, all of these were 60-watt incandescent, which, in addition to the shower vent fan and light, which is also incandescent, drew a mighty 800 watts by itself. That's more than all of the lights in the house now consume when they're all lit. This relay was being shared with the garage fluorescent fixtures, which drew about 300 watts. This means that the half-horsepower relay that these were merged into, probably when another relay failed, was barely sufficient. Yes, I said horsepower. I think these relays were rated this way because their original intent was to control motors and someone couldn't be bothered with conversion, but I could be wrong about that. I do know that my calculations put this at just under 10 amps, 9.8, and other relays of the same model number manufactured in later years were rated for 10 amps, so it's at least backed by evidence. I was drawing about 1,000 watts, or 8.3 amps on a 120-volt circuit, which is slightly over the recommended 80% max constant load. In other words, this was most certainly a no-no bad dog. At any rate, tracking down brown wire pairs randomly distributed throughout the house in a hodgepodge mess with little to no tagging or marking is hard. Just because it isn't hard enough, the pairs that go from the relay box to the switches are only the on and off contacts for the switches themselves. There's sometimes a third or fourth wire for each switch coming from the transformer I mentioned earlier, and subsequently one running from the transformer to the relay box, or from the relay box to the transformer, whatever direction that should be. Sometimes both wires go to the relay box, and then from there 3 or 4 wires to each switch, but really it appears to depend on the installer and how he was feeling that day more than anything else, as this didn't really vary from manufacturer to manufacturer. Combine this with the ability to run more than one switch per switch plate, and it gets worse. This brings me to the weird rotary dial thing in our bedroom. There were several control devices beyond simple toggle switches for these systems, each with interesting features. This is one of those devices. Some people refer to this as a pilot panel. However, that is not what this is. A pilot, or more correctly piloted panel, is simply a control on the system, switch or otherwise, that's lit with an incandescent bulb and requires a special relay with an extra contact to supply continuous power to the light. This also caused a lot of compatibility issues. This is just a master control panel, and you can have as many as you want if you don't mind having 10 times as many wire pairs going to that panel. The double pole rotary switch changes the relay that the momentary switch above it is connected to, allowing you to control a number of circuits in the house remotely. That's remotely in the 1940s. Let's take a moment to appreciate what we have here. What we have here is the first really neat organized way to control circuits in other rooms in your home from one place, and without having to run tons of extra heavier gauge wire or use 3-way switches and the like. Also, on means on. None of that logic gate annoyance you get with some 3-way switch setups where, you put one on and the other one off, and maybe the light's on or off, and if they're both down, maybe it's off, and maybe it's on, and if they're both up, maybe it's on or off, and sticky notes just won't help you. Also, you don't need a panel 5 switches wide to control 5 lights. Also, you could use combinations of these rotary switches to make nearly unlimited circuit addressing. So why did we stop doing this? Well, the answer is slightly more complicated than it may seem, despite my earlier reasons. First and most obvious, these things were expensive, and a lot of people just thought they were more novel than the systems were worth. Another reason seems to be safety, or at least reliability and ease of maintenance. Although these systems are arguably safer in some ways, they weren't as safe as the installers seemed to think, and often the wiring was pretty shoddy, leaving a lot of metal in the relay boxes exposed with rat's nests of wires haphazardly smashed inside, which at the very least could disable the system and burn out relays. I couldn't find any specific instances of fires caused by these systems, but I wouldn't be surprised if that was a concern at least at some point. Additionally, as I mentioned before, there were no sockets or plugs or quick disconnects for swapping the relays, and they were just attached to the mains electric and load lines with wire nuts. The switches had blade connectors on the back, at least for all the ones I've seen myself, but that was the best you got. I suspect there are even installations out there with the twist and tape method. Shudder. They were not user serviceable by any stretch of the modern imagination. The fact that you could potentially shut off one breaker but have some unseen bit of wire touching the metal of a casing or box or relay and make it live or at least ground out the entire operation was also a fear. I took down the whole house by the mains when I performed the surgical procedure on my system. Again, as I mentioned earlier, there might have been some problems with how proprietary everyone's system was as well. Sierra systems were compatible with GE lighting systems, but touchplate required special relays or transformers, and some systems used varying voltages for their piloted switches, which made their relays proprietary. Some systems even used DC instead of AC for the control relay. These seem rare and required extra accessories like rectifiers, but if you tried to switch from one to the other with the standard brown and brown wire pairs without realizing the situation, bad things would likely happen. Also, Some switches weren't momentary for some weird reasons, and the mounting straps were almost always unique to the brand, same for style. So the disparity in system designs meant that there was never a clear frontrunner in these minor ways, and that may have been the final death knell. I'm not really sure. The other issues could have been addressed fairly easily, but there didn't seem to be a point. I'm sure someone will point out that Desperate straps were the most common among these older homes, both in low voltage and normal systems, and even gave way to other fixture designs, but it wasn't really standard, especially in the earlier decades. And if you went with something other than Desperate switches, you were in for even more heartache starting in the 80s and 90s, as even Pass and Seymour, the company that took over Sierra and Desperate, started to be forgotten. Whatever the ultimate reason or reasons, it's too bad we sort of shelved this concept. It turned out to be the perfect foundation for the house of tomorrow. Because of the way the electrical is run, it makes it a lot easier to implement certain ideas. There are other things about this house and the way they were built at the time that have turned out to be extraordinarily great ideas for reasons the builders probably had no knowledge of, but I'll cover those in future videos. Now, almost all of the things that I've done to my house are possible and even pretty easy these days without the 1950s low-voltage lighting system. But it certainly made things easier, and I think we should think ahead to things like this when we're running the wiring in new construction. Not that we don't already. I like the idea of keeping the nasty currents away from the switches you touch, if you must touch a switch in the first place, which is something I'll talk about in great detail over the course of this series. I'd also like to help other people with these systems make use of them, rather than just chalk them up as a nuisance. They were a pretty neat idea, and if you're updating wiring, you might want to consider simply rerouting it as it was originally wired for convenience. So, what did I replace the old solenoid relays with? These, the Shelly 1PM and Shelly 2.5 roller shutter relays. I'll cover the really simple installation, setup, and other details of these in the next video. You can use these in a wide variety of applications, and I aim to cover most of those in this series. While these are only a part of the whole system, they are an integral part, and they're just fantastic to use, in addition to possibly being the thing some of you out there with old low-voltage systems might just be looking for. Another reason this setup and these relays are so brilliant is that I've used many types of smart plugs and switches at our old house to accomplish many of the same things in less accessible areas, but all of them require a cloud application and login of some sort. I didn't like this for a lot of reasons you can assume and argue over in the comments. The Shelly Relays offer what I consider the holy grail of IoT, cloudless implementation. Cloudless IoT. Isn't that like saying an Internet of Things without the Internet? Well, sort of. I can still interact with my house over the Internet, but I can choose the intermediary and to what level my devices are exposed to outside systems, if at all. I can also control my controls, how they look, feel, function, and so on, which is super nice. There are a lot of things out there that do a lot of the things that I'm doing out of the box, but my reasons for doing them myself are many, and I'm not saying my way is the best way. I can say my way is simple, secure, and I would like to think in some ways elegant, but I'm not saying there aren't better, easier, faster, or even safer ways of doing some of these things. Not only did these relays offer me a fantastic and UL certified solution to relay replacement, they added my desired programmability through MQTT, a technology I'll cover in the next video, and they're smaller than the original relays by far. I realize that this setup looks awful and some of you might be cringing, but I assure you two things. One, this is much safer than it looks, and two, I will be installing a proper mounting box. I'm just in the process of designing and making it. I will of course post videos from here on out. You'll notice that there are several small wire pairs going to terminal blocks on the lower right side. Those are currently doing nothing, but there was something there I'll discuss in the next video, and soon there will be something new there that I'll discuss in a future video. Probably not the next one though. Here's a brief overview of what my current system is capable of today. Remember, this is a work in progress, and while I'll be doing videos based on what I've already done, there will be a lot of videos of new features coming as I try to finalize this design to build for others or to show others how to build. Right now, the only thing I'm using from the original lighting system is the actual 120-volt infrastructure. The control infrastructure gave me trouble due to some unique challenges while detecting small currents over long distances. More on that in the next video. As I mentioned before, there were 19 relays in the box, but there were 24 independent circuits. Some of those I've re-separated and controlled independently once more. I've also added relays in other areas of the house that I'll detail as the series progresses. Some implementations are worth dedicated videos. The goal with my system was to enable at least 3 ways to manually interact: web, voice, and touch. although interaction shouldn't be necessary in most cases. We'll talk about that over the course of the series. As it is right now, depending on time of day, light levels, weather, and in some cases climate, when you walk into certain areas of the house, the lights simply come on while you're there and go off while you're not. Some areas are not as aware of occupancy as others, but I'll be documenting the completion of that feature throughout the house as the series progresses. You can override any state with the web app, the touchscreens, or presently with Google Assistant through an if this then that integration that I'll likely abandon later on because it gets little use and I think it leaves a big hole in my security. Plus, I kind of want to try some open source voice recognition. For the moment, it's just sort of there until I replace it. The lights aren't the only things in the house that are connected to the system. There's also fans, heating, and cooling units. I say units because there's a furnace and a smaller unit to heat and cool the game room that was added to the house much later. Various light, temperature, and humidity sensors and some other quirky devices like motor controllers and servers are also connected. The system can not only control and monitor circuit power usage, it is also capable of measuring the temperature and humidity inside at various points and outside in order to make the most efficient use of the furnace, central air, additional HVAC unit, whole house fan, bathroom vent fans, and ceiling and circulation fans located throughout the house to more efficiently add or remove heat energy. I'll have a few videos on this system as the series progresses. The system even knows when there's high amounts of infrared coming through the game room windows, which aren't low E, or at least low E enough, and will shut the roller shades in order to further prevent thermal energy from seeping into the house. So, I hope you've enjoyed this rather lengthy video and maybe even learned something. Please do consider subscribing if you're interested in this project for any reason or if you just like hearing me talk. The next video will cover installation and setup of the Shelly Relays MQTT services and some basic programming using a Raspberry Pi that enables a fair percentage of the niftiness that is my home automation. Thanks for listening to me ramble. Remember, this is a work in progress, and I do hope you'll join me for future videos as I explore building smarter circuits. Also, the creators of these older systems first called them remote wiring systems, which is a better definition, although I prefer the term control voltage variable electromagnetically isolated control.